Hello everybody, and welcome back to our small tutorial series about the smart automation and monitoring system. It's still about more efficiency and effectiveness, and still about how to use and how to work with all these additional information and functionalities in the smart automation and monitoring system. And this time we want to have a look at how we can use these additional information and transport it directly to a connected standard device without using the IO-Link communication. So that means how to use the pin 2, for example, of a SAMS device, and how to put alarmings on these pin 2 and how to connect this directly to a standard device. So we will have a look at this kind of configuration here. You see that normally the SAMS device is connected to a port of an IO-Link master with pin 1, 3 and 4. 1 and 3 is power supply, pin 4 is the communication via IO-Link. And here you can see that we can take the information from pin 2 of a SAMS device and transport this information directly to a connected standard device, for example. This information can be configured as a digital information and can be transported to a digital device, like this digital signal light here, or it can be configured as an analog information and can be transported to an analog device, like we see here in this area. How to do this? We will have a look again at our web server in our IO-Link master, and we will stay with the optical sensor here on port number 1. And what we want to do is to create a kind of alarm situation that we say, okay, if the inclination of this device is bad, or if the vibration of a device is bad, I want to get 2 alarms, and if either one or the other alarm is actual, then I want to put this information directly to a standard device. Okay, so let's start with the configuration of the alarm itself. We will go to the vibration first. That means what we have to do is to set the vibration alarm bit, and we have to say, okay, if the vibration is higher than 1 millimeter per second velocity, then I want to create this alarm bit. So now we see, if we go to the process data, we have this vibration alarm bit, alarm status, and if I create this vibration here, you see that now I'm here at 679 millimeter per second, then the alarm status bit will be set to 1. Now it's not enough. I want to transport this information now directly to a standard device, and this is what I have to do in the pin configuration, because I want to put this alarm bit now on pin number 2. Pin configuration we can find here in our parameter area, and first we can read the settings, how it is configured, and now we see, okay, the pin 2 functionality, we are already here as a digital output, which is okay. Digital output is the correct setting for our case, and the second one we have to do is to select the source, the signal source, so what kind of information I want to transport to pin 2, and we said we want to use the vibration alarm status as a digital output to pin number 2. That's it. And let's go back to the process data, and now I want to connect this standard device here directly with pin number 2 of our device. And now I just took the pin 2 of this device and transported this directly to this standard digital signal light. So whenever I create these vibration now, you see that not only the alarm status is set, but it's also transported directly to the signal light. That's the first thing. Second, we want to do is to say, okay, not only if vibration, but also if inclination alarm is set, then I want to have this as an information on the standard device. So we have to configure the inclination alarm first and say, okay, I want to set the alarm bit and I want to have it whenever the inclination is higher than 15 degrees. That's it. And we want to set this reference orientation, so to say that this is the 0-point position of this device. And the second thing we have to do is to go back to the pin configuration. No, sorry, not to the pin configuration, to the logic blocks, because now we have to combine two different information, the vibration alarm and the inclination alarm, because we want to say that either if vibration or inclination is set to 1, then I want to have this information. And this is what we're doing in the logic blocks. In the logic blocks, you see that we have in total up to 4 different logic blocks available, and with each logic block we can connect up to 4 different signals. First thing we have to do is to select what kind of logic block it should be. Is it AND, OR, NOT OR, or XOR? We say it's an OR connection, and it's an OR connection or combination of the inclination alarm status or the vibration alarm status. So that means either if vibration or inclination, then we have a result of logic block number 1. Okay, we will write that down. And now we have to go back to our pin configuration, because we have to change the signal source. Oh, sorry, here the signal source, because for pin 2 it's not longer only the vibration alarm, but it's the result of logic block number 1. Yeah, we created logic block number 1, or combination of vibration and inclination, and the result is coming from logic block number 1. Okay, we write that down. And now, if we go back to the process data, we see that, of course, still when the vibration alarm is active, then we see it on the standard device. But also, if the vibration alarm disappears, we still have the signal on the light because of the inclination. That is the OR connection, or the connection of a logic block. Again, vibration is one signal and inclination is the other signal. Even if the vibration status is disappeared, then we still have the signal on pin 2. That's how to work with the pin configuration. Thank you very much for your attention, and please have a look at the other videos as well. We will see how to use a smart automation and monitoring system device completely out of an IO-Link or field bus topology, and that will be interesting as well. Thank you very much.